All right. Thanks, everyone. My name is Federico, and I am the head of the Department of Mathematics at Swinburne. And I want to welcome you to this seminar about the Matilda effect. So first of all, let me acknowledge the country, and then I will be very happy to introduce you to Louise, our speaker tonight. We respectfully acknowledge the Wurundjeri people of the Kulin Nation, who are the traditional owners of the land on which Swinburne's Australian campuses are located in Melbourne's East and Outer East, and pay our respect to their elders, past, present, and emerging. So it is a great pleasure for me to introduce Louise, who's been my colleague for, we've been colleagues together for a number of years. She is an outstanding applied mathematician and started her career as a student in Queensland, where she got a number of degrees, including chemistry and mathematics. And then she went on to complete a PhD in applied mathematics / theoretical physics / chemistry in 2005. She's a recipient of a number of very non-trivial awards. First of all, she was a ALC Jackra Fellow, which is a very prestigious fellowship that only 1 out of 4 applicants, even 1 out of 5 most of the time, applicants get. She is currently a Vice Chancellor Women in STEM Fellow, very recently, she was also awarded a Vesky Women Career Recovery Fellowship, and that's even rarer because there are only 7 in the country. She is, of course, also a lecturer in the maths department, and her specialty is mathematical modeling across a number of interesting sectors, including material modeling, damage mechanics, and computational mechanics. Tonight, she will delight us, I'm pretty sure, with a talk on the Matilda effect, and in particular, the history of forgotten women scientists, a few examples of how women have been forgotten throughout the centuries, and they're basically overlooked for their contribution, which most of the time turn out to be fundamental. So thanks very much, Louise, and I'm very looking forward to this presentation. Thanks, everyone.
Thank you, Fede, for that introduction. And again, I just wanted to apologise that this event had to be online due to an unexpected incident on campus. So sorry for anyone that did come to the ATC Lecture Theatre. We hope you're able to join the Zoom online seminar. I'm really excited to give this talk for Matilda Effect for National Science Week. My name is Louise Olsen-Kettle, as Fede mentioned, and I'm a lecturer in the Maths Department at Swinburne. I'd like to acknowledge country too. Sorry, I'm just going to take out my video. Sorry, that makes it a lot easier to read. I'd like to respectively acknowledge the Wurundjeri people of the Kulin Nation, who are the traditional owners of the land on which I'm standing, and pay my respects to their elders past, present, and emerging. The Matilda effect is where the contribution of female scientists is not acknowledged or the credit is given to a male scientist. It was first coined by Margaret Rosita in 1993, and she named it after the suffragist Matilda Gage. Matilda Gage was the first known American woman to publish a study of American women in science. The Matilda effect propagates the STEM gender gap by reinforcing male stereotypes, leading to fewer role models, female role models, and a male-dominated culture leads to less recognition of female achievements. This chart from the US Bureau of Labour Statistics in 2019 shows the percentage of women in different STEM fields. So you can see that in the computing and mathematical sciences and engineering and architecture, there's only between 10 to 20% proportion of women working in these workforce. Whereas for biological science, it gets closer to 30 to 40%, but you can see none of those STEM fields has equal representation of men and women. The gender gap can also be observed in productivity. So there was a paper by Huang and co-workers in the Proceeding of the National Academy of Sciences in 2020, and they showed in their study that the papers in 2005 that just 35% of all authors were female. If you break this down into the STEM fields, this proportion is even less. So for mathematics, physics, computer science, and engineering, the proportion of women authoring papers in these fields is only between 15 and 18%. Another measure that you can sort of observe this gender gap is in the citation. So citation is a metric used often for scientists as an example of how impactful their publication is. So the more citations you have, the better the paper might seem. And Dvorkin and co-workers published this 2020 paper in Nature Neuroscience, where they looked at papers from the top 5 neuroscience journals published before 2016, and then compared them to a random draw model and to see if papers where a man was in the first and last author position, if they were cited more or less often than what would be expected from a random draw. And what they found was that when a man was in the first and last author position, they were cited more often than expected. And when a woman was in either of those positions, they were cited less often. So this is meaningful for scientists, especially early career female scientists, because if their citation is a measure of their work, their worth of their work, then if they're getting cited less, they will be appearing to their colleagues and supervisors as doing less impactful work. Unfortunately, the percentage of female laureates also reflects the gender gap. And as you'll see in this talk, where I think it was up to 8 Matildas that I will be talking about could have received the Nobel Prize who didn't. So the percentage of Nobel Prizes awarded to women is less over all the categories. However, when you look at the STEM categories, so for instance, the Nobel Prize in Physiology or Medicine has only been awarded 12 times to women, so 5.4% of those awarded. In chemistry, it's only been awarded 7 times, which is about 3.7%. And in physics, only 4 women have won the Nobel Prize, which is only 1.8%. In mathematics, there's another medal, which is known as the Fields Medal, which is like the Nobel Prize for maths, and only 2 women have won this, so 3.1% of those awarded. So this brings me to my talk, which is about the Matildas, so the history of forgotten women scientists. And I will apologise that, of course, I couldn't cover every single Matilda. There will be others out there that this talk couldn't cover due to time constraints. I must admit, I found this a fascinating topic to research. So my first Matilda is Theano, who was a 6th century before Common Era Pythagorean philosopher, and she was the first known woman mathematician. There's very little actually known about Theano. She was maybe 1 or 2 people. She could have been the wife or the student of Pythagoras, and it's very likely that a lot of her work was attributed to Pythagoras. She worked on the golden ratio, or what is known as the golden mean, which is phi. And this number is a special number in maths which crops up. And for instance, you can see that this is one of the it crops up in measurements of the Platonic solids. This is one of them, which is a dodecahedron. And it's formed by, it's a shape formed out of 12 regular pentagons. And you can see that in the formula for the volume, the golden ratio crops up in measurements. It's also thought that golden spirals might occur in nature, like in this shell or in spiral galaxies. And a golden spiral is just a spiral that for every quarter of a turn that the spiral makes, it increases its width by a factor of phi, the golden ratio. My second Matilda is Maria Merian, who was a German-born Swiss naturalist in the 17th century. She was unique in that she studied insects in their environment rather than dead specimens. And she refuted the notion of spontaneous generation that was widely held at the time, that insects just spontaneously generated out of mud or water. She did this by breeding butterflies and was one of the first to document metamorphosis in butterflies. She was also possibly one of the first people to document insect parasitism, where flies or wasps hatched instead of butterflies sometimes. In 1699, at the age of 52, Miriam and her daughter set off on their first ever purely scientific expedition to the Dutch colony in South America, Suriname. There she was assisted by the local indigenous and enslaved populations to go on treks and find animals. And you can see in some of her papers, some of her beautiful illustrations. This one is one of a tarantula eating a hummingbird. This is one of leaf cutter ants forming living bridges so that they can either go over water or between branches. And she also documented the amphibian life cycle of frogs. But unfortunately, because of the lack of formal education and her gender, her successors were hesitant to cite her, and some even thought these were flights of fancy, and her work fell into obscurity for decades. And after her death, some inaccuracies crept into copies of her hand paintings. Maria Kirch was a German astronomer born in the 17th century. She was the first woman to discover a comet in 1702. Her husband wrote to King Leopold I the next day describing the discovery, but omitted her name. However, just before his death in 1710, I guess he got a guilty conscience, and he revealed his wife was the one who made the discovery. After her husband's death, Kirch wanted to take over his position as astronomer and calendar maker at the Prussian Academy of Sciences. However, the Academy had already faced ridicule because she had helped her husband already in the past make the calendars. So instead of appointing her, they appointed an inexperienced man to take over the job. However, when he was not up to the tasks, they tried to ask her back as an assistant, but fortunately she already had another job at the time. Her son then later on became Astronomer Royal, and when he did, Kirch and her two daughters worked as his assistants. However, she was asked to remain silent when visitors came to the observatory, and when she refused, the Academy removed her from the residence at the observatory for being too prominent. And this basically ended her scientific career. She published on a few things, and one of them was the conjunction of the Sun with Saturn, Venus, and Jupiter in 1709 and 1712. My fourth, Matilda, was Sophie German, who was a French mathematician born in the 18th century. She loved maths so much that her parents used to try and take away her candles and warm clothes to stop her studying at night. When she was refused entry to the École Polytechnique, she assumed a male student's identity who had dropped out. Her lecturer at the time was Lagrange, and he was so impressed by his new student that he met with her, and then upon meeting Sophie German, offered to tutor her, and he introduced her to other mathematicians such as Legendre and Gauss. In fact, Gauss only learned of German's true identity when a family friend of German in the French army was asked by German to assure his safety in the French occupation of Hanover. German was able to solve Fermat's last theorem for some special primes known as the German primes, where P and 2P plus 1 is also a prime. These German primes are still used today in cryptography, and they're part of the reason that your credit card chip keeps your money safe. In 1811, the Paris Academy of Science offered a prize to anyone who could offer a mathematical theory for why elastic plates on vibration form standing wave patterns. To give an example of what this looks like, this is an elastic plate with sand scattered over it, and as it gets vibrated with a violin bow, you can see that the sand makes these standing wave patterns. And after 3 attempts, Germain was able to win the French Academy of Science prize for her mathematical explanation for the vibration of an elastic surface. And her memoirs on this have laid the foundations for the theory of elasticity and acoustics, which are still used by engineers, material scientists, and musicians today. In fact, in 1814, Poisson also published his work on elasticity. However, he did not acknowledge that Germain had helped him, although they had worked together and he had been a judge on the competition. Her name is also excluded from the Eiffel Tower's list of 72 scientists. My next Matilda is Mary Anning, who was an English fossil collector and paleontologist born in the late 18th century. She was born into extreme poverty, where out of 10 siblings, only Mary and her brother Joseph survived to adulthood. She was born in Lyme Regis, which is known for its Jurassic fossils. And Anning discovered many dinosaurs, including 2 ichthyosaurs, a 9 and 11-foot plesiosaur, a pterosaur, and a new species of plesiosaur over 22 feet. Her work was often claimed by men like William Buckland and William Conybeare, who gave talks and wrote about her discoveries. In 1832, she discovered the head of a large ichthyosaur, but could not get to the rest, so Thomas Hawkins paid to dig up the full fossil. Many of Anning's findings in museums and personal collections today still don't credit her. And working class people at that time often sold fossils to wealthy collectors who got the credit. Many scientists of the day could not believe that a woman with such a deprived background could possess her skills and knowledge. These drawings shown here, where she has recreated what the dinosaur could have looked at like from the remains, show an example of her skill. But unfortunately, due to her social status and her gender, in time, the skills of Mary Anning and her family were forgotten. My sixth Matilda is Nettie Stevens. She was an American biologist born in the 19th century, and she revolutionized biology by demonstrating in mealworms that the sex of each individual is determined by the X and Y pair of chromosomes. She concluded that sex is inherited as a chromosomal factor and that males determine the sex. This refuted the common belief at the time that the mother was responsible for the sex of the child or environmental factors. Edmund Wilson made a similar discovery about the same time and was given the credit for this discovery. However, Stevens' conclusions were more accurate than his. My seventh Matilda is Alice Ball. She was an African-American chemist born in the late 19th century, and she developed a water-soluble injectable form of the Kumulga oil from the Kumulga tree seeds. This was used as an effective treatment for leprosy for 2 decades until the 1940s. Prior to Ball's method, this oil had caused vomiting on ingestion and topical blisters on application to the skin. After her death, Arthur Dean, who was the president of the University of Hawaii, continued her work and published his findings as his own, calling it Dean's method. And soon her injections were in demand and sent all over the world to treat leprosy. However, Dr. Holman, who was also on the island, referred to it as Ball method in his papers. She was the first woman and first African-American to receive a master's degree and become a chemistry professor at the University of Hawaii. My eighth Matilda is Emmy Noether, who was a late 19th century German-born mathematician. She has been described as the most important female mathematician by many, including Einstein. She lived almost her whole life without a salary or little play. And even with a PhD, Noda was not allowed to teach, and much of her research was unpaid and published under colleagues or her students' names. Noda's first and second theorems have been used to derive conserved quantities from symmetry. This ice skater here is a good example of the conservation of total angular momentum. As the ice skater will twirl faster with her arms brought close to her body than when her arms are stretched out. And this is because as her arms are stretched out, her mass is distributed over more space. When she draws her arms in, this distribution is less, and so her speed will increase to counteract that difference. This device is known as a Newton's cradle, and it is a good example of the conservation of linear momentum and energy. And it is 4 balls that are swinging on a pendulum. And you can imagine as you lift the first ball and release it, when it touches the second ball in line, it will transfer its momentum to the second ball, which transfers it to the third ball. And then that transfers it again to the 4th ball. And at the 4th ball, its kinetic energy then changes form to potential energy, and it begins to swing up to a height, and the process starts again. So that's a good example of where her theorems have been used to derive conserved quantities. At the Large Hadron Collider in CERN, physicists are still looking for new particles predicted by Noda's insights. However, Noda was fired in 1932 from Göttingen University because she was Jewish. She immigrated to the US but died shortly after. My 9th Matilda is Rosalind Franklin, who was a British chemist born in the 20th century. She took one of the best photographs, X-ray diffraction photos of the B form of DNA at the time. However, unknown to Franklin, her colleague Wilkins showed this photo and some of her unpublished data to Watson and Crick. Data derived from this photo were instrumental in allowing Wilkins, Watson, and Crick to construct their Nobel Prize winning helical model for DNA. And because she died before the Nobel Prize was awarded, she did not share the prize. However, Crick and Watson felt she deserved to be included in it. My 10th Matilda is Dorothy Anderson, who was an American pediatrician and pathologist born in the 20th century. She was the first person to diagnose cystic fibrosis. This discovery led to the development of diagnostic testing and earlier treatments, where now people with cystic fibrosis have a typical lifespan of 44. Where before her, she identified this disease, often children didn't lead to adulthood. She devised a sweat test with her colleague, Paul de Santagnesi. And this has still the gold standard in cystic fibrosis screening today. However, her role in devising this test was minimized later by de Santagnesi. My 11th Matilda is Clara Dan von Neumann, and she was a Hungarian-American self-taught computer scientist born in the 20th century. She was one of the world's first computer programmers and primary developer of coding for the 1940s ENIAC computer and reprogramming it to make weather predictions. Despite being the programmer, she was not listed as an author in the 1950 paper, Numerical Integration of the Barotropic Vorticity Equation by John von Neumann and Charney. ENIAC was the first programmable electronic general-purpose digital computer. In fact, all first 6 programmers of ENIAC were women. And for decades, historians thought that the women posing in the photographs near ENIAC were just refrigerator ladies, trying to make the computer look better. And you might be surprised to know that at first, in the 40s, computer programming was a female-dominated industry. But as computers have risen in value, this number has shrunk rapidly. And today, only approximately 8% of software developers identify as women or non-binary. So next time you scroll through a weather app to decide if you need an umbrella or not, think of the woman who made it possible to produce the first successful meteorological forecast on a computer. My 12th Matilda is Lise Meitner, who was an Austrian physicist born in the 19th century. She discovered nuclear fission, which is the dramatic splitting of the atom, which has changed our world. Fission occurs when a neutron slams into a heavy atom, forcing it to excite and split into 2 smaller atoms, releasing large amounts of energy and other neutrons that can go on to form a chain reaction. This was the principle behind the first atomic bomb during the World War II, and it's also behind nuclear weapons and nuclear reactors. Meitner discovered the power of nuclear energy after a dramatic escape from Nazi Germany to Sweden in 1938. But unfortunately, it was Meitner's professional partner for over 30 years, Hahn, who received the Nobel Prize in Chemistry as the discoverer of nuclear fission in 1944. Despite the fact that Meitner had directed his most significant experiments and calculated the energy resulting from fission. Her exclusion from the prize was a consequence of her fleeing Nazi Germany and the subsequent social marginalization of her research. My 13th Matilda is Marietta Blau, who was an Austrian physicist born in the 19th century. She was persecuted for her religion as well as her gender. Blau developed photographic nuclear emulsions with industry. This is as a way to take pictures of high energy interactions of nuclear particles. With her PhD student von Bocker in 1937, they discovered what they termed disintegration stars, which were particle paths in the emulsions resulting from the split of a nucleus hit by a cosmic ray. Recording these rare high energy events, nuclear events, forged the field of particle physics. However, it was Powell in 1950 who won the Nobel Prize for physics for applications of the photographic method that Blau had developed. Blau and von Bocker were nominated by Schrödinger for the 1950 Nobel Prize, but did not win. In 1938, Blau fled the annexation of Austria by Germany. Meanwhile, von Bocker and other colleagues who remained continued to publish papers on emulsions and cosmic rays, and had the considerable benefit of Blau's scientific notebooks and data she left when she escaped. Einstein secured her job in Mexico City, but due to a lack of scientific and financial resources, she was largely left unable to continue her research. My 14th Matilda is Chien-Shiung Wu, and she was a Chinese-American experimental and particle physicist born in the 20th century. She's been known as the Chinese Madame Curie and faced both sexism and racism. She was asked by the theoretical physicist Lian Yang to devise an experiment to test the conservation of parity. Parity symmetry states that particle processes, for example, collisions and decays, should happen in the same way if all the positions and orientations are flipped. However, Wu showed using the decay products of the unstable isotope of cobalt-60 that they were emitted preferentially in one direction, and this violated parity symmetry. Parity violation is a major contribution to high energy physics and development of the standard model, which explains 3 out of 4 of the fundamental forces, including electromagnetism and strong and weak interaction. Lian Yang mentioned Wu in their acceptance speech for their Nobel Prize in 1957. However, it wasn't until 1978 that Wu was formally acknowledged for her Wolf Prize in Physics. My 15th Matilda is Esther Lederberg, who was an American microbiologist born in the 20th century. She discovered the bacterial virus Lambda, which infects the bacterial species E. coli. And this has been used widely as a cloning vector, as it is a small piece of DNA that can be stably maintained in an organism into which foreign DNA can be inserted and cloned. She also discovered the bacterial fertility factor F, which allows genes to be transferred by conjugation from one bacterium carrying the factor to another lacking it. However, she devised the first implementation of replica plating, for which her first husband and his research team won the 1958 Nobel Prize for Medicine. Replica plating is where a clone from a master plate is inoculated onto another plate, or allowing several clones to be tested independently. For example, you might expose one clone to antibiotics, and then you could imagine by natural selection and adaptation, the bacteria may gain some antibiotic resistance, and then they can be compared to the clone that didn't get exposed. Textbooks often ignore her work and attribute her accomplishments to her first husband, Joshua Lederberg. After their divorce, she had to fight to stay at Stanford, and she never held a tenured position despite her foundational discoveries in the field of microbiology. My 16th Matilda is Vera Rubin. Rubin's measurements of the speed at which stars orbit around galactic centers established the evidence for the existence of dark matter and its gravitational pull. Newtonian mechanics predict that the rotation of a star around a galactic center would slow down with distance from that center. However, the rotational speed she measured remained more or less constant as far from the center. She postulated that dark matter settles like halos around the galaxies, providing the gravitational pull to keep them stable. She was not nominated for this seminal work for the Nobel Prize. Since then, researchers have shown that only approximately 15% of matter in the universe is normal matter as we know it, and only a small fraction of that emits light. My 17th Matilda is Isabella Carl, who was an American chemist born in the 20th century. She invented practical applications of her husband's theories, which remain the basis of all advanced X-ray crystallography programs today. She showed that if the X-ray wavelength and the distance between atoms in a molecule are approximately equal, then the speed and accuracy of determining molecular structures with X-ray crystallography increases vastly. This has allowed us to determine the structure of complex biological molecules, including proteins, revolutionizing drug development by showing how drugs interact with proteins in the body. In 1985, Jerome, Carl, and Hopman were awarded the Nobel Prize in Chemistry for developing direct methods for analyzing X-ray diffraction data. However, Jerome, Carl, and many others in the crystallography community believe that Isabella Carl should have shared the Nobel Prize. My 18th Matilda is Patricia Barth, who was an American ophthalmologist, inventor, and humanitarian born in the 20th century. She invented a revolutionary device called the laser phaco probe, which uses lasers to remove cataracts, minimizing invasion and risk during surgery. She was the first in many respects, the first African-American resident in ophthalmology at New York University, the first woman faculty member in ophthalmology at UCLA, and the first African-American female doctor to patent a medical invention in 1988. She has restored sight to people who had been blind for over 30 years, and the laser phaco probe is still used today to treat cataracts. She is often seen as a nurse by her colleagues, with one colleague commenting on her invention, "That's impossible. People have been trying to do that for years." But in her words, she always kept her eyes focused on the prize and believed in herself. My 19th Matilda is Ariana Rosenbluff, an American physicist born in the 19th century. She contributed to, but was not named in the Metropolitan algorithm, which is the basis of the Markov chain Monte Carlo method, and wrote the first full implementation of this method. The Markov chain Monte Carlo method is a technique for generating random samplings from high-dimensional probability distributions. It draws samples where the next sample is dependent on the existing sample, called a Markov chain. The game of snakes and ladders can be thought of as a Markov chain, where the player's next move is determined by the player's present position, and the positions on the board can be thought of as a Markov chain. This algorithm has been used to simulate quantum physics and stock markets, forecast political conflict outcomes, and infectious diseases such as COVID. My next three Matildas are Katherine Johnson, Mary Jackson, and Dorothy Vaughan, who were American mathematicians born in the 19th century. You may recognize these women from the movie Hidden Figures, which was based on their lives. They initially worked as human computers for NASA, where initially these women had to work in the West Area Unit, where they were segregated because of their race and their sex. It was their brilliant work that propelled the first American, Glenn, into orbit in 1962. Glenn requested Johnson to do trajectory analysis for his second orbital mission in 1962, in his words, make sure they were safe. Jackson was NASA's first African-American female engineer, and in 2015, Johnson received the Presidential Medal of Freedom, the highest civilian honor in the US. My last, but certainly not least, Matilda for this talk is Jocelyn Bell, who was an Irish astrophysicist born in the 20th century who discovered pulsars. Pulsars are spinning dead stars, which are formed when massive stars collapse and die. As the pulsars spin, they emit radio waves. Pulsars are one of the most useful stars in the planet, and they can be used to test fundamental theories in physics, detect gravitational waves, weigh the solar system, and keep incredibly precise time. Bell noticed an anomaly in data from the 4-acre array radio telescope showing the trace of the first identified pulsar. However, she had to be persistent in reporting this anomaly in the face of skepticism from her PhD advisor, Hewish, who initially insisted that the scruffy pulsars were due to interference and man-made and labelled them little green men. However, this observation is considered one of the greatest astronomical discoveries of the 20th century. In 1974, ironically, it was Hewish, Bell's supervisor, and Ryle who were awarded the first Nobel Prize in observational astronomy for Bell's pulsar discovery. 50 years later, though, Bell has been awarded a special breakthrough prize in fundamental physics in recognition of her contributions. And I thought I'd just take a moment in this talk to also talk about some success stories. So some women scientists who may have been forgotten at the time, or and are slowly gaining recognition, or some are just familiar names we know. So my first, Hypatia was one of the greatest mathematicians during the early 5th century, and also one of the earliest documented female mathematicians. Theon was her father, and it is thought he invented the astrolabe for ship navigation, and it's more than likely she assisted him. She worked on algebraic equations and conic sections. And while she didn't suffer from the Matilda effect, as she did have a huge following, she was murdered in 415 CE by a Christian mob due to politics. Ada Lovelace, born in the 19th century, is recognised now as the world's first programmer. She wrote the first computer program demonstrating how an analytical engine could be used to generate Bernoulli numbers. And some of you may be aware that there is an Ada Lovelace Day. Rebecca Crumpler was the first female African-American doctor, and she had to battle deep-seated prejudice against women and African-Americans in medicine to gain her degree. After graduating, she cared for formerly enslaved people in Virginia, and in 1883, she published her book on medical discourses, providing guidance on maternal and child health. Florence Nightingale is probably one of the best-known female scientists and one of the earliest data scientists. She successfully lobbied government to improve conditions and sanitary measures and expand the role of nurses in the Crimean War. Her infographics showed far more soldiers died from preventable diseases in warfare. And when some doctors thought her sanitary measures a waste of time, Nightingale leaked her charts to the press and eventually forced governments and the armed forces to make better decisions about sanitation. And in the end, she saved lives through her sanitary measures. Marie Curie is another very well-known female scientist and the first person and only person to receive two Nobel Prizes to this day. In 1903, she was awarded with her husband Pierre Curie and Becquerel the Nobel Prize for their work on radiation. And in 1911, Marie Curie was awarded the Nobel Prize in Chemistry for her discovery of the elements radium and polonium. Chemists consider this discovery and isolation of radium to be the greatest discovery since oxygen. Ines Mahaya was a Mexican-American botanist and one of the most successful botanists and female plant collectors of her time. She only began her career at 55 and has had many plant specimens named in her honour. Ruby Painscott was an Australian pioneer in radiophysics and radioastronomy, and she's believed to be the first female radio astronomer. CSIRO has initiated the Painscott Awards to honour her legacy. Grace Hopper was the first woman to earn a PhD in mathematics from Yale University in 1934. In 1952, she created the first computer language compiler, which translates mathematical code into machine-readable code. This was an important step towards creating modern programming languages like Python. She is credited with coining the terms bug and debug. When a computer failure stumped her, she opened the machine and to her surprise, she found a moth, which is the reason we say we debug our computer programs. Flossie Wong-Stoll was a trailblazing HIV researcher who played a key role in showing that HIV causes AIDS. She was the first scientist to clone HIV and show how it evades the immune system and this led to the development of blood tests for HIV. She also showed how the virus mutates and helped develop effective antiviral therapies to manage AIDS. She's a pioneer in human retrovirology. And it's interesting to note that one of her first papers was rejected at first by a referee who didn't believe that human retroviruses like AIDS existed. Isabelle Bear was a mineral chemist who, with her colleague Richard Thomas, were the first scientists to scientifically describe the smell of rain, which is known as petrichor. The smell itself comes about when the humidity before rainfall fills the pores of stones or rocks or soil with tiny amounts of water and flushes the oil from the stone and releases this petrichor into the air. So you can think of Isabelle Bear next time you smell the rain. In 1988, Bear became the first woman to be awarded the Royal Australian Chemical Institute Leighton Memorial Medal. Gladys West is an American mathematician whose mathematical modelling of the shape of the Earth and development of satellite geodesy models have formed the basis of the GPS, or Global Positioning System. So think of this woman next time you open your Google Maps to look for directions to go somewhere. Jane Goodall is a very well-known female scientist as well, who revolutionized our knowledge of chimpanzee behavior. She showed that chimpanzees are omnivorous, can make and use tools, and have highly developed social behaviors. Temple Grandin is an American animal scientist, and she became a hero to America's cattle industry by designing meat processing plant holding pens and walkways that resulted in a more tranquil and efficient process, which was better for the animals and better for the plant workers. Her designs are now used globally as well. Ellen Ochoa was the first Hispanic woman to go to space in 1993. She's a co-inventor on 3 patents, which these inventions have significantly increased our ability to capture and analyze finely detailed imagery and remove noise. And this has applications both in space and on Earth. Mona Hanna-Attisha is a pediatrician and public health advocate whose research exposed the Flint water crisis. She showed that children were being exposed to dangerous levels of lead in Flint and has testified twice about these water issues before the US Congress. Bina Sahajwala is one of Australia's best-known engineers. And I remember Bina Sahajwala as being one of the judges on one of my favourite TV shows at the time, The New Inventors. And she was a great inspiration to me then. She is famous for being the inventor of green steel. And she demonstrated that carbon and hydrogen can be extracted from waste rubber, like car tyres, instead of coking coal in steel production. She's also revolutionised recycling in Australia by introducing small specialised microfactories for e-waste. Nalini Joshi is one of Australia's top mathematicians, and she was the first female professor of mathematics at the University of Sydney. She co-founded the Science in Australia Gender Equity program, which works to increase the retention of women in STEM fields. Her research is in nonlinear differential and difference equations and nonlinear integrable systems. Solitons, as you can see here, and this is some solitons in shallow water, which are waves that move without changing their shape. So in shallow water, occasionally you can get these special types of waves that don't disperse and reform just like the ones we see normally in the sea, but keep their form as they go. And you can see here, and this is an example of an integrable system where the Korteweg-de Vries equation gives rise to these solutions. You might recognize Sarah Gilbert as the designer of the AstraZeneca vaccine. And her vaccine has been shown to show up to 70% protection against COVID-19, but may reach as high as 90%. Lauren Gardner led the team that built the COVID-19 pandemic tracker, which is a website you can go to that has become the authoritative source of COVID-19 case data. It's used by governments, infectious disease researchers, and media globally. This is a New Zealander, Sisu Wiles, who's a public health communicator. and she teamed up with the cartoonist Toby Morris to join forces to communicate the science of the pandemic. And I'm sure we've all had one conversation or multiple conversations with our friends and family on flattening the curve and why some of the measures were taken in the pandemic to try and stop its spread. And their award-winning graphics on flattening the curve have been translated into multiple languages and adapted by governments and organizations globally. So thank you very much for your attention, and I think we have time for some questions. So I'll stop sharing, and yeah, if there are any questions, I'll
Yes, thank you very much, Louise, for this very thorough and fascinating for me, and I think for everyone else. Presentation. It was a great discussion that really went through the centuries. I mean, from ancient times to modern times. Yes, there are some questions. Very selfishly, I will start with one question from me.
Yep.
Do you have a favorite story?
I think Mary Anning, the English paleontologist and fossil collector, just coming from extreme poverty, and they're the ones that were striking to me. I guess, Ada Lovelace has gained a lot of recognition, and she was, so I guess there's, she did have the privilege of being Lord Byron's daughter, so she may have had, but when you see someone like Mary Anning or Alice Ball, who, probably had to face the prejudice as well, that for race and or poverty, that's just, it's very inspiring.
Yeah, thank you. So the first question, which is a bit of a tricky question, but both me and Ant looked this up. So if you don't know,
Okay.
it's easily Googleable.
You can give it if I don't.
Mansplaining, sorry about this, just because we're in theme. I'm just joking. So it's about the fact that one of the French scientists that you presented did not have a name on carved on the Eiffel Tower.
Oh yeah, yeah.
Was asked.
Man.
All the others are actually male scientists.
Yeah,
probably.
I don't know. Maybe, but do you know better? I can't remember.
They're all male.
I had a feeling they would be. Because if she wasn't going to make the cut, I don't know who else would out of the French side.
Yeah, that's a good way of thinking. There's a question from Karen about all the Matildas that you researched. There was one that was like a very big surprise. What was the biggest surprise or shock to you personally? I guess if I can interpret this question and sort of add, which is a beautiful question, also something from my end. I guess shocking goes both ways, like for the utter, anger of sort of what's going on here. This is an absolute disgrace. This is just an injustice, but also at the same time, like I guess the idea of an incredible discovery that was not acknowledged. Is there one in particular for you?
I would say Marietta Blau and Lise Meitner, who both had to flee Nazi Germany, and couldn't continue their work. Not necessarily shock, but the fact that they didn't get the recognition afterwards while they were alive, and also a lot of these women had were very poor later on, you know, so they didn't get much pay. I was surprised at how many died young, even though I know like back then they did, people did die earlier, but it did seem a lot of them died very young. There's a lot of marriage breakdowns.
Yep.
One thing I did notice that I thought was great was there was so many computer programmers that were females, and they really drove the industry at the start. And yeah, so that would be great if we could turn that around again.
Yep. Thanks. So move on. There's a question from Tony. What do you think are some of the strongest barriers that still face women scientists today?
I would say it's the fact that often we are the primary carers, either being for children or for parents or whatever the case. So we often end up being the primary carer. So that does lead to, you know, a lot of hidden work that we're doing and keeping all the juggling in our brains. I think that is not acknowledged. Yeah, but I also recognize that this isn't, you know, always the case. Yeah.
Thank you. This is not a question, but I think it's a nice suggestion from Julia about Mary Anning. She says that there's a great historical fiction novel that is called, the title is Remarkable Creatures. And the writer is Tracy Chevalier. And she highly recommends that. So,
oh, great. Yeah. Yeah, I think a few of these women have had books. I think Dorothy Anderson might have one written about her, and Ines Mahaya has.
Yeah.
Yeah. Yeah.
Yeah. So there's another question from Carolina. It's a very deep question. So a very, very fascinating question too. Thank you, Carolina. So how do you think that those successful stories can be shared more broadly to raise awareness and also influence gender equality policies and that can help inspire as well, you know, future female scientists? You know, we have a big problem in maths, Louise, about girls, you know, and how good they are and how discouraged, unfortunately, they are by some teachers, you know, and parents and career advisors into continuing their journey and contribute. And so any ideas about this, about, you know,
well,
stories? Yeah.
I would say there has been some progress, like we have an Ada Lovelace Day. I know Alice Ball is celebrated in Hawaii. They actually have a day of celebration for her. That's a bit more local. There are more books being made, like fiction books, not fiction, children's books based on these women's lives. In fact, some of these stories came from a book I gave my daughter, which was stories for about rebel girls or something.
Yeah, Susan just
sorry, I'm forgetting the title, but yeah, so I think, you know, and Rebel Stories for Girls, thank you. And she just loved reading that. And so actually some of those ladies that I presented today was from there. I was trying to get as broad a picture as I could. And in fact, there was still people I wanted to fit in the talk, but I only had 44 minutes. So yeah, there are, yeah, I think the more we can talk about these scientists with our daughters and buy these books, yeah, it's probably one of the ways. I'm not sure I know all the ways, but I think that will help.
Okay, I've got another couple of questions, and then if there are no more questions, we'll wrap it up. So slightly different than what you've showed at the beginning, a question from Roya, is more about how often this story happen nowadays. So in your opinion, how much of this, and by this I think we mean the fact that women are completely ignored and, you know, bullied, and sometimes, you know, even worse on the workplace, and non-acknowledged nowadays in science and engineering in particular. Do you think it is widespread? Do you think it was widespread and it's sort of getting better? Any clue about this? Any insight, please?
Well, I mean, I guess some of the graphs I showed at the start did show that, you know, female authors, the proportion of female authors in papers is increasing, although looking at the STEM fields, not so much. But you could see that it was increasing in time, the overall percentage. But then looking at the 2020 paper with the citations where women are cited less, and if we're going to use that as a metric, then, you know, maybe if there was a way we could allow for this, I don't know. It's all very complicated with metrics. I don't think they're always the best way to measure our worth, but it is what is used, so it will affect us. Yeah. I think I might have gone off topic there.
No, I think you are on topic. I think my 2 cents, you know, is that there is more propensity to withdraw papers nowadays, I think, because there's more scrutiny, and you know, Retraction Watch, for example, is a website that publishes which papers are retracted or rejected, or, you know, just taken aback because there's been some flaws, and sometimes, you know, this also boils down to non-acknowledging everyone that participated. So I think there are more instruments to try and curb the tendency of disregarding women, hopefully. So maybe I'm too optimistic, but, you know, I think.
Yeah.
I got 2 questions, and then I think we should wrap up. So one is from Julia, and it's about those stories that have not yet been uncovered. So she notes that there are times where people contributed, but the names are not included. And this is not a question, she says, about whether they did it or not, but sort of how do we find out later? So in some of the stories, how this thing actually this covered up and you know, non-acknowledgement were discovered, for example.
Sorry, I've lost my train of thought. Sorry, can you just
sometimes, you know,
I'm sorry.
Don't know about the uncovering or sort of the neglecting.
Yeah.
30 years. So how do?
Yeah, I think I think one of the things that was interesting to me is that, for instance, when there were a lot of computer programmers were women, and they did a lot of the what we would consider now, if you were writing the code and implementing it and running the program and doing all that practical work, you would be a co-author. But I think back then you could see that possibly these women weren't regarded as co-authors in the 50s and 40s. That just was seen as sort of the layman work, and they were doing the real work, so they got to be the authors, or they got to get the prize. I saw a lot of cases where the woman was doing a lot of the practical applications, like maybe the implementation of the computer method, or designing the X-ray crystallography applications. So yeah, I think also the way we have sort of changed in what it means to be a co-author. And I think there are papers, when you do publish, there are a lot of journals now that are asking for you to report what your contribution was. So I think we are getting better. Yeah.
Yep. Okay, so the very last question, it's from Rosalie, and it sort of touches on some of the things you just said. And she notes, being from chemistry, that there's a number of very disturbing cases, some like Dorothy Hodgkin, for example, Rosalind Franklin, in crystallography. And she was just wondering whether you think there are disciplines that are more involved than others.
Yeah, I mean, certainly in my talk, there was a big percentage of women scientists that were Matildas, that were computer programmers, that weren't recognized because the programming was sort of seen as the menial work. And whereas now we wouldn't see it as that at all. And we would give equal emphasis to both. Yeah, like I said, I think I did notice that a lot of the women, like for instance, Chien-Shiung Wu was doing the practical application. So she devised the practical experiment to test parity symmetry, but she was not recognized for that. It was the theoreticians who just asked for the experiment that were recognized. So I did see a lot of cases where I thought the women actually did a lot more of the practical work, which really actually surprised me.
Yeah. Okay. Let me thank you again, Louise, on behalf of the whole department, Swinburne, and essentially the audience. And I'm sure that everyone enjoyed immensely your talk. We will discuss whether we can share your presentation to all the attendees, because
We can, yes, it'll be shared.
Okay, good. That's great news. You know, thank you so much, and happy Science Week to everyone.
Thank you. Happy Science Week.
And take care, you all. Bye-bye.